Hello. In this session, we'll set up our AutoCAD file and look at the basic drawing and modify tools that will enable us to do our orthographic and isometric projections. Let's go. AutoCAD is a very complex piece of software, and we'll only be looking at a small handful of its tool set to do our orthographic and isometric drawings. It's a little important that we don't get lost because there's a lot more that we can be doing. So, with that in mind, let's look at setting up our file and then add a small handful of the tools that we'll be using for the drawing itself. Let's go. So when you start AutoCAD the first time, you'll see a start page like this. And there'll be a small button that lets you start a new file. Now this layout will look a little different depending on which version you're working on, but you will have this button somewhere. So if you start, you end up with a blank file that looks like this. There should be nothing in it. But this file is actually drawing upon something called a template, which is a set of file options and taskbar settings that are just predetermined so that we save a little bit of time in the initial setup. We don't have to do it over and over again. And all of those templates are available right below this start button for me. And for you, it might be on a separate drop down in the start page, but it will be there. Uh, there'll be a set of templates already loaded here. You can select one and see what happens. Eventually, we'll be making our own template at the end of this session, um, and that should be very useful henceforth. But for now, we'll just go with what AutoCAD calls its default blank template. It calls it acad.dwt. So if I click that, I end up with a blank file, and the file is exactly the same as this because by default, right, AutoCAD just uses this ACAD template for everything. For the rest of this session, you can see whatever inputs I'm giving in the lower right hand corner. Left click, right click. If I type anything, you can see that there as well. And that's important because a lot of the things that you can do in AutoCAD are executed in a much faster manner with keyboard shortcuts and commands. In the amount of time it takes me to execute one of these, I can pretty much be done with it twice as fast by using keyboard commands. And that's one of the secrets to becoming good at AutoCAD. You need to work with the shortcuts wherever possible. So for this entire session and the forthcoming sessions as well, I will be sharing as many of those as I can. So when you start up AutoCAD the first time, you will see your entire toolset on top. It's divided into these tabs. If for some reason you don't see the tools expanded, there's this little button in the top right hand corner of this section. If you click it, it's going to toggle between the different viewing options. All right. We want the one that's usually expanded so that we see all our tools. Further, in this area, which we call the workspace, where you do all of your drawing, you want to be in a standard viewport with a standard viewing angle. So you can do that in multiple ways, but the easiest one would be to click on this little drop down and select 2D wireframe. You get a different kind of shading depending on what you select here. But right now we want to limit ourselves to the 2D wireframe mode. Also, everything that we'll be doing will be in what we call the top view, which should be mirrored here in the little navigation gizmo. Alright, so this is your main drawing area. And if you want to start drawing, you can just pick a tool, let's say line, which is in the home tab, and then click somewhere. And you start your line command. You can click again, click, and you can keep on doing this. You'll keep on adding more lines, right? When you are done, you can press escape and you get out of it. So that's the basic way you input any drawing objects. If you want to make a circle, for example, you just click on that tool, click somewhere for the center, and then you can click again and you make a circle, right? But of course, AutoCAD is a precision tool, so there's lots more ways that you can input these objects and get a lot more precision that way. We'll look at that in a few moments as well. But before we do, there are a few more things that we need to set up in this file before we can start. The first thing is the workspace itself. So in this lower right hand corner, this thing is called a status bar. You can see a bunch of things such as coordinates, a few settings, and this little cog icon. This is called the workspace switcher, and there are a bunch of preset workspaces available over here. If you want to work in the one that says drafting and annotation, in later versions it might be called 2D drafting, but it's usually there. There's also workspaces set up for modeling. So if I click on one of those, you'll notice that the entire tool set here changes. The layouts are different. We don't want that right now. We just want to work with 2D tools. So let's switch to drafting and annotation. Then there are some other settings you want to enable here. Uh, if you're not able to see any of these, you can click on this little hamburger menu at the bottom right and enable or disable whether a setting is visible. So for example, this button, it's called the dynamic input toggle. This one, if I just uncheck it, it's no longer shown in this section. It is still turned on, it's not shown. And in my version of AutoCAD, clicking on the button toggles between an on and off state. Turning it blue turns it on, turning it gray turns it off. Right? So for most of our work, there are a few things we'll want turned on. And if they're not visible, again, please enable them here. The first one is dynamic input. We'll be seeing what these things are as we go along, all right? Then there's these two snapping buttons. Then there's this button called line weight or LW display. Just turn it on. Again, if it's not visible, you can go here, enable its visibility first, and then turn it on. Further, in this little drop down next to the object snap button, if you click on it, you get a bunch of settings with checkboxes. We'll ignore those for now. Just click on the button that says object snap settings, and you get this box. And all of these tabs, you want to work on the object snapping tab. And there are a bunch of tick marks here as well. We just want to say select all, and then we'll say OK. And again, I'll explain what these things are as we go along. All right, so that sets up the interface and the layout and the buttons to what we want. One last thing you might want to keep on is this coordinates. If it's not on, again, just toggle it on and off from here. And that will show you what is underneath the mouse cursor. If I move it, as you can see, the X and Y coordinates keep changing. The Z coordinate remains at 0 because we are essentially working on a top-down view of a three-dimensional space where the Z coordinate of the plane that we're working on is 0 at all points of time. All right, now's a good time to save our file because we've done a little bit of work in it. All right, what I'll do is I'm going to delete everything and then I'll say save and I'll just save it. In this case, I'll put it on my desktop. Give it a good file name, and you will have newer versions to save in if you're working on a version older than 2017, but I'm going to stick to the default file format here. AutoCAD saves its files in this extension .dwg. It is important to save your file initially because that way, as you continue working, AutoCAD keeps making incremental backups of your work. So in case you have a power failure or your system crashes, you will have some kind of backup to work back upon. If you don't save your file, there's a chance AutoCAD might not make backups of your work at all, in which case you could lose hours on hours of work. So remember to save your file initially. All right, continuing on with just the basic file setup. Next, we're going to look at object properties. So I'll just make a line again, and we will see how to do these things in depth in a few moments. Don't worry about that. Uh, every object in AutoCAD can have three basic properties. There's the color, there's the thickness of the line, which is called line weight, and there's the line type. Okay, so if you want to modify any property, you first have to select whatever you want to change the properties for, and then you can change its properties from this little drop down. This is again available in the Home tab. So if I want to change the color of this line, I can just select it here. And there are a bunch of variations. We'll talk about them in a moment. But if I just change it, the line's color changes. If I want to change its thickness, I can select again and select one of the thicknesses. Let's try 0.3 millimeters. Now, if I select that, you can see that the line has become thicker. But there's a setting down here that enables or disables the visibility of that thickness, and that's this line weight button. So if I turn it off, you don't see the thickness anymore. Oftentimes, this is one of the things that ends up happening when you're working. You apply thicknesses and they're not visible. This is usually the reason. So enable it. The third property that we can change for any object, well, as long as it's 2D, of course, is the lines property in terms of type. So as of now, there's one line type loaded called continuous. We'll talk about layers and blocks in a while. I'm going to say other on this box. You get this kind of box after that. Or in AutoCAD, anywhere, you can just type line type in the command prompt and enter. You get this box again. I'm going to load a few line types by clicking that load button. Now, for our purposes, we just need two new line types. There's one called center, and then there's one called dashed. All right. So the only line types we are working with are these three: continuous, center, and dash. And we'll see what each of those do as we go along. I'm going to say OK here, and then I'll select this line and apply one of these line types. As you can see, it's changed the line type, right? All right, great. If I want to apply the other one, I can just select that as well. So now it's dashed. All right, next I'm going to show you how to show the dimensions for all of these. I'll make a small line of 100 units for that, so that I know that it's supposed to show me 100 when I show its dimensions. Now, the way you do dimensioning, there are multiple options. There's a small annotation section in the Home tab, and then there's the whole Annotate tab itself, where there's a expanded dimensions section. And you can do basic dimensioning from both of these. So if I want to show the length of this line, there's a quick dimensioning button as well, but I tend to ignore that because it doesn't always give us the kind of results we want. I'm going to use this little drop down panel instead. I'll use the one called linear, and then I'll click on the left edge, click on the right edge, and then click outside. Okay. Now you see that something has happened. It's just that you can't really see what this is, and that's because the dimension text is pretty small. Further, the arrows are pretty small as well. So let's change that. Now, the thing about AutoCAD is you can change properties for practically everything on a per object basis, the way we just did. But it's a lot more convenient to just change settings across the entire file so that we don't have to keep applying properties over and over. So for that reason, instead of changing its properties here, which we'll see later as well, what I'll do instead is I'll change the global dimension properties. So for that, I'll go to the Annotate tab, and in this dimensions section, I'll click on this downward arrow in the bottom right section. I get a box like this. I can also just type dim style in the command prompt and I get the same box. I say modify, and I'll leave the lines tab alone. On the symbols and arrows tab, I'll increase the arrow size. I'll keep it around 5. And this number is going to be dependent on the overall dimensions of the file you're working with. Right now, 5 should be a good enough number. Let's test it out. Okay. On the text tab, I'll increase the text height. I'll keep it around 5 as well. Then in the text placement section, I'll make the vertical placement above so that the dimension text comes above the dimension line. And then the text alignment section, I'll turn it to ISO standard so that this text turns by 90 degrees. These are orthographic dimensioning conventions. We need to stick to them. Further, I'll go to primary units, and in this precision section, I'll just turn the precision to 0. You usually don't want to see numbers after the decimal. AutoCAD automatically rounds things off for you. Say OK, and I'll say close here. All right, much better. So now I can clearly see what the dimension is. If I want to show a vertical dimension, I just make a vertical line here. Let's say 50 units. And if I show its dimension using the linear option, right? So it's always 3 clicks. Click once for your first point, click once again for your ending point, and then click to place the arrow and the text. All right. Now, if I want to show the length of this line, it's an inclined line, and I use the linear option. What ends up happening is I'll click and I'll click, but AutoCAD will try to show me either the vertical or the horizontal distance between those 2 points. That's not what I want. So I'll use the aligned option instead. And that way, when I click and I click and I click, I see the length that I'm expecting. Okay. If I want to show the angle between any 2 lines, I can pick angular. And then I click on one of them, I click on the other, and then I click once again to place the dimension. If I want to show the radius or the diameter of any curve, I can select the radius option or the diameter option. They work the same way. I'll click on the circumference of the curve and I'll click outside. Similarly for diameter, click and then click. This is basic dimension. Next, we are going to look at the text tool because a lot of our drawings are going to have annotations in them. So the easiest tool to work with here is the M-text tool that's available here. That's short for multi-line text, or it's in the annotate tab as well. Or as long as you don't have any other command running, you can just type M-text in the command prompt and you start it. This works similar to text boxes in any presentation software like PowerPoint, wherein you click and then you click again. You make a text box with that. But things work a little differently in AutoCAD afterwards. So after you do that, you'll get a small text input section like this. And if you type something, you'll usually be able to see it on your screen. But if you exit out, you can't see it anymore. That's because by default, the text height is pretty small. In AutoCAD, the font size is referred to as text height, right? So let's fix that. What you can do here is, I'm zooming in a little bit, you can select this and then double click and then highlight and then I'll press delete. What I'll do afterwards is, in this section here, I'm going to increase the text height. I'll keep it around 5 and enter. Now your cursor is going to look pretty big. If you type something, it's going to vanish practically out of the screen. Just say close text editor and get out, right? It should be much bigger compared to the drawing after that. All right. So the way you should be executing the text tool is you type mtext in the command prompt and then you make a text box. And then increase the text height in the beginning itself. Let's say we keep it around 5 again. And then we test things out. Right? And then once you get out, you can see what's happening. All right. You might have noticed me moving the screen around quite a lot. Let's talk about that. This is basic navigation. And for this, what I recommend is that you all have a 3-button mouse with a scroll wheel because otherwise it is possible but a lot more cumbersome, right? So the way you work with navigation is you press and hold the scroll wheel and your cursor turns to this hand. Then if you move your mouse around, what you're doing is called panning. You're just changing your viewport to look at different paths, right? Similarly, if you just move your scroll wheel, you scroll forwards, you zoom in, you scroll backwards, you zoom out. It is possible for you to zoom out too much. You get lost. You don't know where you are. In that case, the easiest way to fix it is to type the Z key on your keyboard. That starts the zoom tool, as you can see, and then type E. And that's just going to reset your viewport till everything is visible. One more time, you type Z, enter, then E, enter. Right? It works the same way the other way around as well. So if you're zoomed in too much and you don't know where you are anymore, just do Z, enter, E, enter. Right? That's basic navigation. The next thing I'll show you is selection. I'll make a few random objects for that. And again, don't worry, we're about to see how objects work in a little bit short. All right, so there are a lot of tools and objects on the screen right now. And there are multiple ways of selecting these things if you want to work with them. So the basic way, the most default way is to click on an object. It gets highlighted. You can keep on adding to that selection by clicking on more objects. But this can get cumbersome. It might not seem that way, but when your drawing becomes a little more complicated, like let's say this, it's difficult to select, let's say, just everything in this section with this method. So there are a couple of other ways you can make selections. The first one is called a blue box because it is a blue box. The way it works is you click your left mouse button somewhere in empty space. You click and release, don't click and hold. And then you move your mouse, you drag out this blue box, and then you click again. All right, one more time, click, release, and click. This box is going to select whatever's completely inside its borders. So if I do that around this circle, you'll notice it selected this line as well because it was completely contained inside it. But it didn't select anything else that cut its corners or borders. On the other hand, if I click somewhere in empty space and instead of going to the right, I move to the left, then I make a green box. And this selects whatever's inside it as well as whatever's cutting its borders. So as you can see, it selected these three circles. This may not feel very powerful, but when you know how it works, it can be extremely powerful. So now, for example, if I want to select just this, I can make a blue box around. It did not select any of these yellow lines at all. If I want to select just these yellow lines, I can make a small green box around it. It didn't select any of these. Whereas if I tried to select these yellow lines with a blue box, I'd end up selecting a lot of additional content that I didn't want. So selection boxes, they're pretty powerful once you know how they work. The last thing we need to see before we can start working on our drawings is layers. And you can find the entire layers section on the home tab here. You can see if I open this drop down, it's showing me two layers right now. There's one called 0 and one called def points. On the other hand, if I go back to this file, there should be a bunch of additional layers. All right. Now, layers can also be very useful if you know how to use them. In this file, for example, I have layers set up for these thicker white lines and layers set up for these yellow lines and so on and so forth. So once I'm done with my drawing, if I only want to see these white line objects and I don't want to see any of these yellow lines, right? I can open this little drop down and this light bulb next to each of these layers turns them on or off from the display. So if I just click on this for now, I don't see my yellow lines anymore because they're all on this layer called projections. If I turn it back on, it's back again. Along the same lines, you can also do something called locking a layer. So let's say I do that for this object layer where all of my white thick lines are. If I turn it on, then you see that the lines become a little dimmer. What that means is that now this layer cannot be edited in any way. I'm going to type Control A. That's a shortcut for selecting everything in a file. And I'm going to press delete. That's the command for deleting whatever you selected. Now, ideally, it should be deleting everything because everything is selected. But if I do the delete command, it's not going to touch whatever's on the object layer because that layer was locked from editing. So this is useful in certain cases. We'll see that as we go along. All right, I'll just do Control Z a few times to undo that deletion. That's the command for undoing things in most software. All right, so let's make a few new layers in this file. I'll click on this layer properties button. I get this little box there. All right, so let's make a few new layers. You can use this button for that, new layer. Or you can just type Alt N after clicking in this space a couple of times. Right? And we'll be requiring all the layers that I'm making right now. Center lines. All right, cool. So these are all standard constituents of an orthographic drawing. We'll have a layer with our object lines, a layer for hidden lines, for projections, and so on and so forth. Now, all of these layers can let you play around with the three basic properties. So for example, I can turn my projections layer to a different color. I'm just clicking this little swatch for that. And you get a much bigger swatch selection box. There are multiple variations of colors available here, but we'll limit ourselves to these ones at the bottom, right? So I'm going to select the color that says yellow for my projections. I'll similarly turn my dimensions layer to this green. Now there are two variations of white available. There's one that says white in the label here, and then there's this white that says 255. You should stay away from this 255 because this gets printed as white lines whenever you take a physical printout. What you want is to select this white, which gets converted to black lines in a printout automatically. AutoCAD does that for you, right? All right, we are not changing any of the colors here, but we can if you want to. Along the same lines, I'll take my hidden layer and change its line type to hashed, showing us these two line types because we loaded it in the file a few minutes ago. Otherwise, it would just show me this continuous type and say OK. And for the center layer, I'll change the line type to center. Further, I'll make my object layers thickness as 0.3 because that's standard for the kind of drawings we are doing in this syllabus anyway. Uh, and for the hidden layer, again, I'll change the lines thickness to 0.3. All right, we don't need to change any other settings for the kind of work we are doing, but you can if you want. All right, so after that, we have a bunch of layers. So now we can start manipulating our objects. Let's say these are supposed to be object lines. What I can do is I can select them first, and then I can just switch them over to the object. You'll notice that the lines have become thicker. These objects have inherited the properties of the layer. And they've done that because over here everything is saying by layer. If I want to override that, what I can do is I can select the thing I want to override the properties for and select custom properties here. So let's say I change these objects' colors to, let's say, cyan. Okay, it doesn't affect anything that's on the object layer. If I now move these two things on the object layer as well, their color doesn't change. All right, but a good rule of thumb is to not apply per object properties anymore, to just stick with layers because that way you don't add an unnecessary level of confusion to your work. So I switch it back to pi layer. All right, now let's say these are supposed to be center lines, but they are supposed to be on the center layer. So let's switch them. Now I'm not sure if you can see if anything has changed, right? If I zoom in, you'll see the line type is being applied along the same lines. Let's say these are supposed to be hidden lines and they belong on the layer called hidden, which has the dashed line type applied. Again, you can't see much of a difference until you zoom in. So that's happening because the default line type scale in AutoCAD is pretty low. So let's fix that. For that, you go to this third drop down in the properties section and say other. You get this box. Or you can type line type in the command prompt and enter, and you get the same box. There are two scaling factors you can play around with. I tend to not work with the current object scale at all. I just change the global scale factor. I'll try a value of 5 and see what that's like. Doesn't seem to have made much of a difference, right? Let's see if it applied it properly. I'll increase it further. I'll make it 10, let's say. Now you can see there's a little bit of difference happening. Let's keep on increasing it till it's visible to our naked eye. Let's keep it around 15. This is good enough, right? If you keep going higher and higher and that's not working out, you may have to go down to fractions, let's say 0 0.9, 0 0.8, because sometimes the internal default scale for these line types becomes different for different machines. All right. Okay, so that's one way of working with layers. You can just select the thing you want to move and move it to whatever layer you want to keep it on. The other way is to switch to a layer first. So let's say I only want to make lines that are of the projection type. I'll switch to the projections layer. And then I'll click the tool, and then whatever I make on that layer inherits the properties of that layer. We are pretty much done setting up this file by this point. Everything that we need is there. Our line types, our dimensions, our layers, and these basic settings at the bottom. So what we'll do now is we'll save this file as a template so that the next time we come to work on AutoCAD, we don't have to start from scratch. So what I'll do is I'll press Ctrl A to select everything and then delete it all because I want this file to be blank initially. All right, then I'll say save as, and then instead of saving it as a drawing file, I'll select the template option. It should switch over to the templates folder on your machine, and then you can save it as a template. You can call it whatever you want. Let's say I call it a CAD template. Please be careful. You don't want to override any of these default templates because you might run into trouble that way later down the line. So give it a unique name. You'll see that it's already giving me a file called a CAD template.dwt, but that's just because I made it previously to demonstrate the very same thing. So it's fine if I'm overriding this, but don't override any of these older ones by accident. All right, as I save, it should give me a message asking me if I'm sure. I just say yes here. And then you can give it a little bit of basic description so that you remember what you've done in this file. So in this file, I've set up line types, I've set up dimensions, I've set up layers, basic settings, all right? And I'll just say okay. All right, so now we are editing the template file. Whatever changes we make here will be saved in that template, but that's not what we want. So now what I'll do is I'll just close AutoCAD. And then if I start it again, now if I click on this little drop down that shows me templates, I should see my template in the list. It's acad.template. And again, for you guys, you might have to open up the browse button and it should navigate to the templates folder. All right, so I'll select the template I've made. All right, so here all of my settings are set. My layers are set, my line properties are set, and if I go to my dimensions options, then you'll see that even there my standard sizes are set. I don't need to change any of that again. I can just start drawing. All right, but you still need to save your file first because until you do, nothing gets saved. I'll just replace this file for now. All right, so after doing all of this, we are finally ready to draw. So let's draw. We'll start with the most basic 2D tool that we have in our tool set. That's the line command. And you can start it with this button here. But a faster way of doing it is whenever there's no command running, you can just type L in the command prompt. The command prompt is either going to take input right next to the cursor if you have this dynamic input button on, or if you don't, it'll just take input in this little command bar at the bottom. I'm going to keep it on because we'll be using it quite a lot. All right, so now if I type L, it takes input there and it shows me all the commands that start with the letter L. We want to use the one that says line. So I can just press enter since that's the default thing that gets selected. Once again, L and enter, right? Okay, and then if you click somewhere, you make a line. Now you'll notice that if I'm moving my mouse, I'm making horizontal or vertical lines. Further, I'm making them in a yellow color because I'm on the projections layer. All right. Now, these horizontal and vertical lines are that way because I've kept this little button on, the one that says ortho mode. If I turn it off, I'll be making lines at any angle depending on where my mouse cursor is. So if I just click again, I've made my line. And if I keep on clicking, I can keep on making lines. But we want to make lines with precision. We want to tell AutoCAD how long our line should be and what their starting and ending points should be. So the way you do that is by using coordinate systems. And in AutoCAD, there are quite a few, but I'll be showing you just the essentials. We are looking at relative input and polar input for entering coordinates. So once again, I'll start the line tool. And for my first point, I'll just click somewhere. Now for the second point, let's say I want this line to be a horizontal line of 50 units length. I can enter at the rate and then the x and y coordinates with respect to this previous point. So now if I say 50 comma 0, it's made a line of 50 units length and it's horizontal. But you'll notice that it's a very small line because I'm zoomed out a little bit. So let's zoom in. And then I just make sure that I keep my screen where I want to see it. Okay. Next, if I want to make a vertical line here, I can now say at the rate and then the x coordinate and the y coordinates with respect to this previous point. So I'll say 0, comma, let's say the line is of 100 units length, so 100. Then if I want to make this a rectangle, for the coordinates of this third point, I'll say at the rate minus 50, comma 0. Because in AutoCAD, whenever you go towards the left of a point, that direction is considered to be negative. Enter. And similarly, if I want to go down, I'll say at the rate 0, comma minus 100. So that way, AutoCAD understands that I'm going in the downward direction. That's how AutoCAD interprets negative values for coordinates. I'll press enter. And then I can click outside if I want to make more lines, or I can just press escape to get out. Okay. One more time. For lines, I can click somewhere for the first point, and then I can just specify x and y coordinate values, but with reference to the previous point. This is called the relative coordinate entry. So at the rate 50 comma 0, at the rate 0 comma 100, at the rate minus 50 comma 0, at the rate 0 comma minus 1. The at the rate key is the signifier to specify that you're doing relative input. All right. Sometimes you might want to make lines at specific angles to the horizontal. So for that, you will use polar coordinates. So once again, line tool. I'll click somewhere for the first point. And now if I want to make a square of, let's say, 50 mm size inclined to the horizontal at 45 degrees, I can say at the rate and enter the distance first. And now instead of entering x comma y values, I'm entering r and theta. That's the radius and the inclination. We are doing polar coordinates. So 50 becomes r. And then instead of comma, I'll use the less than sign. And then I'll enter the value of the angle. And the way AutoCAD measures angles is when you enter a positive value, the angle is turned in an anti-clockwise sense. When you enter a negative value, it gets turned in a clockwise sense. So now if I enter 45 here, it turns in a anti-clockwise sense. All right, for the next point, I'll say at the rate 50. Now the angle should be 90 plus 45, so 135. One more time, line command at the rate 50, and the angle is 135. For the next point, it'll be at the rate 50 again, and now the angle is either 180 plus 45 in the positive direction or 90 plus 45 in the negative direction. So let's try minus 135. That works. Yeah. And then for the last one, I'll say at the rate 50 and then the less than sign. And now the angle will be minus 45. Once I'm done, I'll press escape. So that is polar entry. Now, oftentimes you don't really need coordinates. All you really need is the starting point and a distance because AutoCAD has a lot of guidelines that help you out. So for example, I start the line command. I'll turn ortho on again because that way we can make just horizontal and vertical lines. So I'll select it and then I just start my first point somewhere. And if I move my mouse, I'm making a horizontal line. Now if I enter a distance of 50 and enter, it makes that horizontal line for me. I need not worry about coordinates anymore if that's what I'm doing. If I want to make a vertical line of 100 units, same process. Leftwards, 50, downwards, 100, and then I'll press escape to get out. Alright, now you might have noticed these little green lines appearing from time to time. These are called tracking lines, and the color is different in different versions of AutoCAD, but that's essentially what they are. And the way you get them is you have some command running, and you just keep your mouse at some point of reference. You don't click anything, no left clicks, no right clicks. Just keep your mouse there for a moment and then move your mouse. And you get these guidelines that show you a continuation of that previous line in this case, or a line that's perpendicular to that line in this case, right? And you can do that for pretty much any object. So if I do that here, I just press my mouse here and then I move my mouse. It's just showing me a continuation of that inclined line. So if I start a line here now, right, and I extend this line to that afterwards, it's going to connect exactly at the starting. And that is useful in cases where these kind of things become relevant. All right. Along the same lines, if I have a command running, you will have seen these little icons that appear when my mouse is at specific points, right? So here it's showing me the square icon, which represents the end point of a line. Here it's showing me the midpoint, that's a triangular icon, and so on and so forth. So these icons are appearing because these buttons are on. And further, what icons are shown to you depends on which of these are checked. You usually want them all on, right? You want to see endpoints, midpoints, centers, and so on and so forth. So that's the reason why I asked you to say select all here initially. All right. Now let's say I want to make a circle. Now the default way is center radius, where first you pick a center and then you enter the radius. So if this circle has a radius of 25, I enter that. Once more, circle, click for a center and then a radius. Let's say it's 50. All right, now let's say I want to make concentric circles. I want a circle around this of that radius 50. So I'll say circle, and now I'll just move my mouse on the circumference of this for a moment. You should see its center snap. You can use that afterwards. You can just click and then drag your mouse out a little bit and enter the value of the radius 50. Okay, one more time. Circumference, click, and let's say 75. All right. Now, if I want to make a circle like this and I want it inscribed inside this rectangle at its center so that their centroids go inside, there are multiple ways of doing it. One way to do it with construction lines would be to make a line like this and then use its midpoint as the center for the circle. And then I can just snap it for the radius here. I just click again. But sometimes you don't need to make these kind of construction lines if you know what you're doing. So for example, I'll keep my mouse at this midpoint and then I'll just move my mouse down. I'm taking a vertical tracking guideline from here. I do the same thing here from the midpoint. I'll take a horizontal tracking guideline and then wherever they meet, it should show me that intersection. So that gets me that center. Then I can do this. But there's a much faster way of making this kind of a circle, which is inscribed between two surfaces. It's called 2 points method, and it's inside the circle command. So it's available here, or since there's a keyboard shortcut that goes with the circle command, I'll use that instead. You just type C and then enter. It asks you for your default center radius method, which is what we've been seeing so far. So you can just click for a center and then enter a radius, right? But there are all these other options inside that menu. There's this 3p, 2p, and tan radius. We'll see all of those. I'll start with 2p first. So I'll select 2p from these options and enter. And then I'll select this endpoint as the first point, and then this endpoint as the second. So what AutoCAD does is it fits a circle between those 2 points. Those 2 points essentially end up becoming the endpoints of the diameter of the circle. Okay, then there's 3p, which is usually used to circumscribe a circle around something. So here I can just click and click, and it's circumscribed. All right, and then there's tan radius, which is a little different. So I'll just type C and then select TTR. So this command, the way it works is you specify two surfaces. Let's say I specify this as the first surface. I've just clicked on it, and this as the second one. I've clicked on it, and then it asks for a radius. So let's say I enter a radius of 10 units. And what AutoCAD does is it tries to fit a circle of that radius between these two tangential surfaces. Right? I'm saying tries because sometimes it doesn't work. I'll explain what I mean. Let's use the TTR command again, and I'll click here. I'll click here, and now let's say the radius is 20. Let's do that again. Circle TTR and click, click, and let's say the radius is 25. So now this circle should be perfectly inscribed inside the square, which has a side length of 50 mm. All right, let's keep going higher. So TTR second, and now let's enter a radius of 100. Yeah. So what ended up happening here is AutoCAD extended these lines out on both sides till it found 2 points where a circle of radius 100 could fit. All right. So it tries to do what it can, but sometimes it doesn't work at all. So for example, if I do TTR here between these two surfaces, now I know that this length is 50. So if I enter a radius of 24, that's a diameter of 48, that's not going to fit here at all. And along the same lines, if I enter a radius of, let's say, 26, that's a diameter of 52, it won't fit in this length. But if I enter 50, it should work. That's 25 radius, but it doesn't. That's because it can't figure out which point on this line and which point on this line are the points it needs to consider, because this distance is constant throughout. So in such a case, the faster way is to use 2p. Right? And that's how you make circles. And believe it or not, almost 90% of all of your drawings in AutoCAD for orthographic and isometric projections will comprise of lines and circles. So in this, for example, that's all I've used. Everything is either a line or a circle or a part of a circle. So the next thing we'll see is how to modify these basic lines and circles to get these kind of drawings. Let's go. Now we're going to see the last set of commands for this session, and those are all available in this modify section. So we're going to look at move, copy, rotate, mirror, and the trim tool. We'll also look at offset, although I don't end up using it a lot. All right. So move and copy work similar to cut and paste and copy and paste in other programs, as in you select something and then you cut it from one place and move it somewhere else. Now, if I'm panning my screen with this scroll wheel, I'm not really moving the location of any of these points with respect to AutoCAD's fixed origin. But if I use the move command, that's what I am doing. I'm changing the location of these objects with reference to AutoCAD's origin. Okay, so if I select all of this and I say move, I can do that from this button here, or I can just type move in the command prompt and enter. It asks me for a base point. So this becomes the point that acts as a reference, as the initial location of your selection. So if I select this center as that base point, I just click. And now if I move my mouse, you'll see that the object is stuck to my mouse, specifically at the point which I selected as the base point. So now I can just click somewhere else and it's moved there. But again, you can get a lot more precision than what I just did. So I can select all this and I can say move. I'll select the center once again as the base point. And now if I say at the rate 100, 0, what AutoCAD will do is it will move my object 100 units to the right. I'll repeat. So I'll select this, I'll say move. Now let's try a different base point because the base point is just a reference. It can be any point that's convenient for you. I'll click and now I'll say at the rate 0, 100. So now it moved the whole thing up by 100 units. But of course you can specify distances with relative input if you want to. So if I select this and I say copy and I select this center as the base point, and if I enter the coordinates as let's say at the rate 200, 0, it's made a copy to its right at 200 units. I can keep on making these kind of copies. I can say at the rate 0, let's say 400, 0, then at the rate 600, 0. All right. And then I can do that for this entire row. So I can say copy here. I'll select this base point. I'll move my mouse up. I'll say at the rate, let's say 0, 200 in this case. And at the rate 0, 400, and so on and so forth. That's the copy tool. Next we have rotate. Now rotate rotates your selection as it suggests. So if I select something and I say rotate here, or I just say ROT in the command, I'll select a base point again. But the difference here is that this time the base point becomes the center of rotation. So if this is that point and I rotate, you'll notice that I'm rotating in 90-degree intervals here because ortho is on. If I turn it off, I can rotate at any angle. And again, here I can enter specific angle values. A positive value turns the selection in an anti-clockwise sense. A negative value turns it clockwise. So if I enter, let's say 30, it just turned it by 30 degrees, and so on and so forth. Okay, the next tool is mirror. And as the name suggests, it's used to create flipped copies around the line. So if I want to do that for this selection, I can select it first and then I'll start the mirror tool from here, or I can just say MI and enter. And then I'll pick 2 points on my mirror line. So the line doesn't need to exist. I can just have a random line like this. I'll click once and I'll click again. Or I can base it around some reference if I'm trying to achieve a particular outcome. Right? So one more time, I'll select this and I'll say mirror. And again, I'll pick random points. After I'm done with the second point, it asks me if I want to erase the source. If I say yes here, it's going to delete this and keep this. You usually want both those, so I'll say no. Right? Now let's try something. I'm going to select all of this and I'll say mirror. I'm going to use, let's say, the tangent points of these two circles for the mirror. Okay, and I'll say no here. So again, if you know what kind of shape you want to achieve, this tool can be useful. All right, the next tool is trim. And for me, the trim tool along with the copy tool are the two most important tools in AutoCAD for 2D line drawing as far as modification goes. Okay, so the way the trim tool works is, and I'm showing you the fastest way because let's not go about it in the slow way, right? You say Control A, that selects everything. Then you start your tool, that's TR, and enter. Or you can just click this button, it's the same thing. And afterwards, you just click on any part of your object that you want to get rid of. So let's say it's this part, I can click on it. Okay. The thing to remember though is that trim only works on objects that are extending beyond other objects. So now this line ends here. It's not extending beyond it. It won't be able to remove this portion. This line, on the other hand, it's extending on either side of this line, so I can remove this or this side. Now, neither of these two is going to be removed with trim. So if you want to get rid of them, you'll have to get out of the trim command first, then select it, and then press delete. Now, this doesn't look powerful, but it is, trust me. So I'll show you a couple of ways, right? I have a circle, and I want to make a semicircle out of it. Now, there are ways of getting it with the polyline tool and the arc tool as separate objects, but I already have a circle with me. The fastest way of doing it would be to make a diameter line like this, right? Then you do Control A, TR, enter, and then just remove the portion that you want to get rid of. Similarly, if you want to make a quarter circle, so Control A, TR, and then just get rid of it. If you want to make 1/8 of the sector of a circle, I just find the midpoint of this arc using the midpoint of snap. Control A, TR. You'll notice that it did not delete this line because it's a complete line. It's not crossing anything else. So if you want to get rid of it, you just select and delete. So that's the trim tool. And the last tool that I'll show you is the offset tool. So offset is used to make parallel lines. Let's say I want to make lines parallel to this, above and below it. I'll select, I'll say offset. That's this button. Or you can type offset in the command. And then it asks you for a distance. Let's say the distance is uniform, it's 10. And then it asks you which side of your object do you want your copy. If you click the upper side, it makes a copy above it or below it. If you select, all right. So click, and then you can keep on doing. Okay, and this has its use cases. Okay, now let's look at a simple example that we can make with everything we've learned so far. Doesn't take a lot of time once you know what you're doing. So I'm going to take a circle. I'll take another circle. I'll just move it in a little bit. I'll make a couple of lines. And then I'll say Control A and TR and enter. And this might look familiar. Okay, that was a lot of work to just make a couple of lines and circles, but in the next session, we'll see how to turn all of that into a complete orthographic drawing. I'll see you.